Motion and time. Motion is the change in position of an object with respect to time. Motion can be uniform or non-uniform depending on whether the object moves at a constant or varying speed. Circular motion occurs when an object moves in a circular path. Speed is the measure of how fast an object is moving. Velocity is the measure of how fast an object is moving in a particular direction. Acceleration is the measure of how fast an object's velocity is changing. The SI unit of speed is meters per second. The SI unit of distance is meters. The SI unit of time is seconds. The SI unit of acceleration is meters per second squared. Speed can be calculated using the formula speed is equal to distance by time. Velocity can be calculated using the formula velocity is equal to displacement by time. Acceleration can be calculated using the formula acceleration is equal to final velocity minus initial velocity by time. Distance is the total path covered by an object in motion. Displacement is the distance and direction between the starting and ending positions of an object. A distance time graph shows the distance an object has travelled at different times. A velocity time graph shows the velocity of an object at different times. The slope of a distance time graph indicates the speed of an object. The slope of a velocity time graph indicates the acceleration of an object. An object at rest has a speed of 0. The motion of an object can be represented as a vector quantity. The direction of an object's motion is indicated by the direction of the vector quantity. Motion is relative to a frame of reference. Time is a measure of the duration of an event. Time can be measured using a clock or a stopwatch. The accuracy of a clock is determined by its precision and stability. The International System of Units is the globally accepted system of measurement. The fundamental unit of SI are meter, second and kilogram. The derived units of SI are speed, acceleration and force. The speed of light is constant and is approximately 3 into 10 to the power 8 meters per second. The Galileo's experiment showed that objects of different masses fall at the same rate in a vacuum. The laws of motion were discovered by Sir Isaac Newton. The first law of motion states that an object at rest will remain at rest and an object in motion will continue to move at a constant speed in a straight line unless acted upon by an external force. The second law of motion states that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. The third law of motion states that for every action there is an equal and opposite reaction. Friction is the force that opposes the motion of an object. Friction can be reduced by using lubricants or by making the surfaces smoother. Air resistance is the force that opposes the motion of an object through air. The shape and size of an object affect its air resistance. Terminal velocity is the maximum velocity that a falling object can achieve due to air resistance. Newton's law of universal gravitation states that every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The weight of an object is the force with which it is attracted towards the center of the earth due to gravity. The weight of an object is proportional to its mass. The unit of force is Newton. The force required to accelerate a 1 kilogram mass at a rate of 1 meter per second squared is 1 Newton. The weight of an object can be calculated using the formula weight is equal to mass into acceleration due to the gravity. The acceleration due to gravity on the Earth's surface is approximately 9.8 meters per second squared. The time period of a pendulum is the time it takes for the pendulum to complete one oscillation. The time period of a pendulum is proportional to the square root of its length and inversely proportional to the square root of the acceleration due to the gravity. Activity. Explain with an activity to measure the time period of a pendulum. Aim. To measure the time period of a pendulum. Materials required: string, bob, stopwatch. Procedure. Set up a simple pendulum with a thread, a string of length nearly 1 meter. Let the bob of the pendulum come to rest at its mean position. Switch off fans nearby. Mark the mean position of the bob on the floor below it or on the wall behind it. To measure the time period of the pendulum, we need a stopwatch. To set the pendulum in motion, gently hold the bob and move it slightly to one side. Make sure that the string attached to the bob is tight while you displace it. Now, release the bob from its displaced position. The bob is not to be pushed when it is released. Note the time on the clock when the bob is at its mean position. Instead of the mean position, you may note the time when the bob is at one of its extreme positions. Measure the time the pendulum takes to complete 20 oscillations. Repeat the activity a few times and record your observations. By dividing the time taken for 20 oscillations by 20, we get the time taken for one oscillation. Length of the string is equal to 100 centimeters. Time taken for 20 oscillations. Time period 1. 42. 2.1. 2. 40, 2.0, 3, 41, 2.05, 4, 41, 2.05.